Hello everyone. Today we are revising the contents of week 3 which are there in Statistics 1 course, and we are starting with descriptive measures, right? Yes. So descriptive measures. What are descriptive measures? As the word suggests, this word resembles with the word describe, right? What does describe mean? Describe means to elaborate or to explain something, right? So descriptive measures are those measures which are required to describe a particular data set, right? These measures are helpful to describe some particular data set, right? There are of two kinds. The first ones are measures of central tendency, and the second one is measures of dispersion, right? There are two of these things, and let's start with measures of central tendency. Okay, let's first try to understand what these two means actually, right? So what happens, the measure of central tendency tells you that what is the center of the data set, right? Center of the data set means where all the data sets are concentrated, type of thing we can say, right? But the measures of dispersion tells about how much the data is scattered, right? And what is the variability of the data, right? So we'll see all of these points later in this video. So let's start with measures of central tendency, right? Measures of central tendency. What are these? So measures of central tendency are most typically, we can say, the center of the data set, right? They tell about the center of the data set, right? They tell you about such a value which can be regarded as a representative of all the values, which is the center of all the values, right? So measures of central tendency are there are a lot of them, right? The first one which we have to study in our course is the mean, right? Mean. What is a mean? So mean are of again many kinds, but here we have to study the arithmetic mean. Okay, mean are of many kinds such as harmonic mean, geometric mean, but here we will take mean as the arithmetic mean, and this mean is defined as sum of observations upon number of observations, right? So this is the basic definition of mean. But the mean is again classified in two parts, in two types, which are population mean and the sample mean, right? Population mean, population mean, which is nothing but sum of so let us first take this, that there are x1, x2, x3 and so on up to x something n, and here in between there is some x small n, right? And n is less than n, right? So we can take it. So population mean is the sum of all the observations upon number of all the observations, right? So x1 plus x2 plus x3 and so on up to xn upon this n, right? Because there are capital N observations in our data set, right? So this is population mean, and it is generally regarded as or denoted as mu, right? The next term here is the concept of sample mean, right? x1 plus x2 plus x3 and upon x small n upon n, and this is denoted by x and a dash, right? So this is your population mean and this is your sample. Now what does this mean? What does mean means, right? So let us take an example through which will be becoming more clear. So let us have some data sets with discrete values such as 2, 12, 5, 7, 6, 7 and 3, right? So we are asked to find the mean, right? So if it is not given that what kind of mean you need to find, just find this, we'll take it as sample mean, or we'll just denote the general mean as x dash, right? But if the term comes that it's a population mean, then we have to use this mu, right? But if it is not given, if anything is not given, that what the mean, what type of mean we have to find, either population mean or sample mean, then we'll just find, or we'll just denote that mean with this x dash, right? So this point should be clear. So how many observations are there? 1, 2, 3, 4, 5, 6, 7. There are 7 observations, right? So there are 7 observations. So I'm writing 7 in the denominator, and I'll add all these observations because this thing is stated in our definition, right? 1, 2, 3, 4, 5, 6, 7. All the 7 observations are here, and the sum of these observations are 42 upon 7, which is equal to 6. So what does this 6 mean? Actually, this 6 is nothing but a value which we can associate with all of these people. Let's try to think this in this way, that these are marks out of, let's say, since there is a 12 out of 15, right? So what is the average marks? That means how many marks? 6 is that marks which we can associate with all of the students, right? So this is actually the center, or which with that center which we can associate with all, because actually the work of mean, or the we can say the utility of mean, is this only, that it provides a value which we can associate with all values, right? Which can be a representative of all values, right? So this is one measure of central tendency. Now let's try to understand some of the variations of mean, right? Mean does not comes with such discrete values always, right? Sometimes mean is there in some continuous frequency distribution, right? So let us try to think about the continuous distribution, or we can say frequency distribution. So it's there in the week 3 that we can arrange our data in classes, right? So these classes can be like 10 to 20, 20 to 30, 30 to 40, right? And the condition in these classes is that this particular point is included, okay, and this is excluded, right? This point is excluded. That means this class will contain all those values which are in between 10 and 20, where 10 is included and 20 is not included, right? So this is an important point which you should keep in mind, right? So if we say that there is a class, right, there is a class from A to B, let us suppose, okay, so we define its midpoint, or we can say we define its class mark, right, which is denoted by xi for this class, is nothing but the mean of these 2 points, right? A plus B by 2. Okay, so we'll use this point in our while finding the mean of the continuous frequency distribution. So let us suppose that there are some classes, right? Let us suppose there are some classes like 10 to 20. Let us take 3 classes only, 20 to 30 and 30 to 40, right? These are the class intervals, and there are some frequencies. Let us denote them Fi, right? Fi, that means frequency of ith class. So let us this be F1, f2, f3. Some frequencies are there. I'm not writing the frequencies, right? Or yes. Then we can't just find the mean using all these things. We have to find, because there is an interval. How can you interpret, or how can you extract some important notion to use it in finding a mean, right? So for this we use this term as class mark, which is nothing but the mean value of this particular class. So for this class it's 15, for this class it is 25, and for this class it is what, 35. Now what we do is that we multiply this fi and xi, right? We multiply this fi and xi and find out the values, and then we sum all of these values, right? We sum all of the values and we denote as sigma of fi xi, right? And the value which is obtained here is then divided by the total the frequency, let us that be n. Okay, total frequency is n. Then the mean becomes sigma of fi xi upon n, right? So this is the mean if we are having a continuous distribution, continuous frequency distribution, right? So let's move ahead. Oh, one point I missed, right? So yeah, what happens when there is a frequency, right? Like 2 2 2 3 3 4 4, and we are asked to find the mean. So we can just first make a table, value, tally mark, and frequency, right? For this, and the values of 2 are 3, so the number of occurrences of 2 is 3. For 3 it's 2, and for 4 it's again 2, right? So what is happening actually, let us find the mean of this value. It's what it would be, 2 plus 2 plus 2 plus 3 plus 3 plus 4 plus 4, right? Upon how many values? 1 2 3 4 5 6 7 values are there. So we can write this as 2 into 3 plus 3 into 2 plus 4 into 2 upon 7, right? So what, if we take this values as xi's, right? Actually the work of these values here is done by class mark in the continuous frequency distribution. So we can write fi. What is the frequency? Let us take the fi for the ith value. Okay, so for the first value the frequency is 3, so we can just write it as what, fi xi, right? Plus or f1 x1 for the first value, and again that formula is 2, that fi into xi, and its summation upon the number of values, right? So this is also, I think it's clear and revised. Let's move ahead. Yeah, now let us try to disturb the data and see what happens to the mean, right? Let's try to do this. Yeah, so what happens if we add a constant to the data set, all values of the data set? So this means that the values which were xi previously becomes yi, and which is equal to xi plus c, right? All the values which were xi, that means x1, x2, x3 and so on, are now becoming what, x1 plus c, x2 plus c, x3 plus c, and so on, and this value will take as y1, y2, y3 and so on, right? So what is the effect? Okay, what is the effect of all these things which we did here? So actually what happens that, Yeah, so if all these values are becoming y1, y2, y3, but it is a notable point that the number of values is n, right? So what happens next? So if we try to find the mean, let's take that mean to be y dash, which is equal to y1, y2, and so on up to yn, let us say, n upon n. So this is nothing but x1 plus c plus x2 plus c plus x3 plus c plus and so on up to xn plus c, right, upon n. Okay, so what we can do is that we can take all these things in one side, xn, and take a bracket, and then we can add all the c's. Okay, so adding c's n time would be nothing but n times c, right, upon n. So by the rules of fraction, we know that we can distribute the denominator upon n plus nc upon n. So this n will get cancelled and we are left with c here. And what this thing is actually? This thing is nothing but x dash, right? So the value of y dash, that is the altered data set, if we alter it by adding c to all the data points, is the old mean plus the constant which has been added to all the values, right? So this is an important point which we discussed. Similarly, if we would follow this process, then we can find what if we multiply a constant, multiplying a constant, right? So if all the values become some yi which is equal to xi into c, then what happens? Then y dash is equal to c times x dash. Okay, this is the point to be remembered. Okay, so yeah, nothing is left. Yeah, let's move forward to the next measure, which is median. Yes, median. So median is nothing but middle value in the ordered list, right? So if we arrange what this actually, what this word is of great emphasis, I would say, ordered list. What order? It can be either increasing order or decreasing order, and the middle value which we will get is actually the median. Okay, so yes, let's take an example, like we are having 2, 4, 1, 7, 8. Okay, and we are asked to find the median, right? So the first thing is to make it an ordered list, right? So ordered list will be like this: 1, 2, 4, 7, and 8, right? So what is the mid value? Middle value means a value uh, which actually is in the middle, and in the left of its, in the left of that value, there are some numbers of data points, and the same number is there in the right of that. So we can say that it's 4 here, right? Because in the left of 4 there are 2 values, and in the right of 4 there are 2 values, right? So median of this data set is what? 4. Okay, so we can generalize it. Okay, before generalizing, we let's take this, like we are increasing one more point, let it be 6, right? Sorry, then we have to again arrange it, because this arrangement is not valid. for this data point. Now let's do it here. So it would become 1, 2, 4, 6, 7 and 8. So now the number of data points here are, you can say that there are 6. They are 6 in number, right? So if we want to find one number which can be considered as the middle value, it's not possible, because if we take 4 as the middle value, then 4 for 4 there are 2 values and then there are 3 values here, right? And if we take 6 as our middle value, then again this story will repeat, that there are, then in the left there would be 3 and in the right there would be 2. So what we do is that we take both of these values, okay, both of these values, and we can say if we take both of these values, then we are left with 2 in the left and 2 in the right. But a median can't be 2 values. So we will do, you know, we'll do a trick, or we'll use our mind and we'll just find the mean of these two values, which is equal to 5. So the median is 5 is the median, right? So 5 is the median of this data set where there are even number of discrete data values, right? So let us try to generalize it, okay? Median of n discrete data values, or we can say data points, would be number 1, n plus 1 upon 2th observation or the value, and yes, and for the if n is odd, and n by 2th plus n by 2 plus 1th upon 2 would be the median. So this won't be an observation, because or the data point, because it's a mean. So it would be the average of two middle data points, right? So I'm not writing observation here. So if n is even, clear? And one condition for all of these is that there should be ordered list. First thing is that you should make this the given data points, or you should arrange them in some order, which is either it can be, you know, increasing or decreasing, anything. IIT Madras videos says that it should be increasing, but they can be decreasing also, okay? So no problem. Yeah, so let's move ahead and see and try to alter the data and try to see what happens to the median, okay? So adding a constant. So you can see that median is only, you know, is not that representative as mean, okay? It's only dependent on one value. So it is not considered as an ideal measure of central tendency. So median is actually dependent upon one value. So the new median would be the old median plus c, okay? So if we have 1, 2, 3, 4 and 5 as our data set, and we are adding 2 to each of them, so it becomes 3, it becomes 4, it becomes 5, it becomes 6, it becomes what, 7. Now the old mean was 3, the new mean is 5, which is nothing but 5 is equal to 3 plus 2. This is your new median. This was your old median, right? So I think this is clear. Now again, similarly we can conclude that if we multiply a constant, then the result would be same. So new median, not same, similar, is equal to old median multiplied by C, right? So all these things we should keep in our mind. Okay. Yeah, one more concept. Till now we studied what are mean, median and all these things, but let us try to think, and we have, we have also studied what is the effect of different kind of altered values. But what happens if we put a value which is, which is not like others, not like the others value, either it is very large or it is very low, very less than the, the all these value combined, right? So that kind of value is known as outliers. Outlier. So let us move ahead. Yeah. So let us take this value 2, 3, 7, 8, and let it be 11, right? And let us try to find out the mean first, right? So this is our, let us say, A. Okay, this is the A data set. Mean would be 2 plus 3 plus 5, sorry, not 5, it's 7 plus 8 plus 11.5, right? So it would be 5 plus 7, 12, 12 plus 8, 20, 20 plus 11, 30, right? So it would be 6.2 something, right? Yeah, 6.2 would be the mean. But what is the median? Median, right? What is the median? Median is 7. We can see that n, or the number of observations, is what? 1, 2, 3, 4, 5. So n is 5. So we know that n plus 1 upon 2th observation is the median, which is equal to 5 plus 1 upon 2, which is third observation. Which is, what is the third observation? It's 7. So median is 7, right? Median is 7. Very nice. Let us just take one more data set, and we'll call it as B. Okay, we'll call it B, and it would be same till 8. 2, 3, 7, 8. And now what we are doing, we are altering this value 11, and we are putting, let us say, 30, right? We are putting 30. So you can see that so long as the data is there until 8, it's quite, we can say that they are quite near. These two values are very near, and these two values are very near, but these two values are a bit far, but not that far. But if we compare these two values, they are extremely far, or we can say that they are like very far neighbors. Okay, so 30 can be considered as an outlier. We have added an outlier in it. Okay, so let us now find the mean. Okay, so mean would be 2 plus 3 plus 7 plus 8 plus 30 upon 5. Yes. Now what it would be? It would be 50, right? Because till this it's yes, 50 upon 5, which is equal to 10, right? So, and now let us again find the median. What is the median? The median is again the third observation, which is nothing but your 7. Okay, 7 is the median. Okay, so 7 is the median. Now what we can conclude, in both the data sets A and B, the values are same until 8, right? But in the data set A, the point 11 is quite near to 8, so it can't be considered as an outlier. But here in B, 30 can be considered as an outlier, and you can see that there is a huge difference between the means of these two data. That means we can conclude again that outliers also alter the value of mean, whereas median, you can see, is unaffected. Okay, median is unaffected. So this is a notable, or we can say, or I can say that this is a very important point, that mean is sensitive to the outliers, whereas median isn't, right? Median isn't. Okay, so let's now move ahead with a new concept which is called as mode. So mode is nothing but the highest occurring value in the data set. Okay, mode is what? Most frequently occurring value. Most frequently occurring value. That value which has occurred a lot of times, or the more, or the largest number of times, or the most number of times, will be regarded as the mode of that data set. Okay, so let us take this example as 2, 12, 7, 8, 9, 2, 7, 3, 7. Okay, so what we can do is to get the mod is that we can simply make a frequency table, right? So the values which this data set takes is 2, 3, 7, 2, 3, 7, 8, 9 and 12. So 2 are 2 in number, I'm not making the tally marks. 3 is 1, 7, 1, 2, 3, 3 are in number, 8 is 1, okay, 9 is 1, and 12 is 1. So what is the most occurring value here? It's nothing but our 7, right? 7 occurs uh, 3 times, which is the most or the largest number of times. So 7 is the mode of the data. Now again you can see that mod is not that kind of representative as mean, because it's again just dependent, or we can say it's found out using just one value. Okay, so it's again not that representative, and that's its we can say that it's drawback. Okay, now again we can multiply a constant. So the new mod will be nothing but old mod into C, or the constant which we have multiplied, and the similar result would be for adding a constant, right? new mod is equal to old mod plus C, because they are all dependent upon one value, and if something happens to that value, then it doesn't matter because the number of that value is same in the data set. The value has changed due to alter or due to what we have altered. Okay, yeah. So till now we have studied everything which was there in week 3 for the concept of measures of central tendency. Now comes the concept of measures of dispersion. Measures of dispersion, right? So here the word is dispersion, right? Dispersion. This resembles the word disperse. What does disperse means? To scatter around. Okay. After an assembly in a school, it's said that assembly disperse. That means you can scatter around and go to your classes. Okay. So measures of dispersion tells us about the scatteredness of data. How much is data scattered, right? And we can say that how much is the variability of data, right? So measures of dispersion are actually helpful in telling these 2 points. Why they are needed? Because this measures of dispersion comes under the topic of descriptive measures. We can't say anything about the data if we don't know how, if we have found out what is its central value and all these things, but how much it is scattered, how the value, how much distance are there in between two values, right? This is also an important point. That's why measures of dispersion comes under descriptive measures. Okay, so what are these measures of dispersion? So we'll start with range, then variance, then standard deviation, then at last interquartile range. Okay, interquartile range. Now let us start with range. Okay, range is nothing but difference between largest and smallest values. So we can just write range is equal to the maximum value subtract minus minimum value. Okay, so this is the range, and it's not a very hard concept. And again we can see that it's dependent upon two values only, which is the maximum and the minimum. But again you should keep in mind that the outliers, which outliers, if they are present, then they would be either maximum or minimum. Okay, they are at the maximum point in between, or they can be two, but they are at the maximum. They are responsible to making something a maximum point, or they themselves will be the maximum or minimum point. So that's why we can conclude that range is sensitive to outliers. Okay, range is sensitive to outliers, and again it is not very representative. Okay, not representative, because we can't say just by using two values that how much is the data set is scattered, right? It's just a difference between the maximum and minimum value. So this is the drawback of this particular point is drawback of range. Yes, yeah. The next point here is variance, and this is a very important as well as new type of concept, variance. Okay, so variance is that kind of measure of dispersion which take all observations in account. Okay, it's very representative, but it has its own drawback, which we'll see later. Okay, so if we have said that please find the population variance. Okay, population variance, then we can say that variance is denoted by this sigma squared. Okay, sigma squared is equal to x1 minus mu square, x2 minus mu square, and so long up to xn minus mu square upon this is not small n, this is capital N upon n. Okay, so this is the this is the value of population variance. And what is mu? Mu is the population mean, which we have discussed earlier. Okay, so this should be kept in mind. And the other point is sample variance. Sample variance is sigma square is equal to x1 minus x dash squared, x2 minus x dash squared, plus up to so on xn upon xn minus x dash squared upon small n minus 1. Okay, yes, this is the thing which is quite remembering, which this should be committed to the memory. Okay, because generally it happens that we take these two as analogous and just put small n, which would be wrong. So n minus 1 is the denominator of sample variance, where n is the size of sample. Okay, let us look at this closely. Okay, so what is this value, that something xi minus mu, or we can say xi minus xi is some observation, ith observation upon x dash. These two things are known as deviations. Okay, these are deviations, deviation about mean. Okay, how much is these ith values are deviated with respect to the mean. So if the mean is population mean, then mu would be taken in account, and then if it is sample, then x dash is taken into account. Okay, so yes, x dash, as we know, it's sample mean, and mu is population mean. So these two things are actually deviations. Okay, these called as deviations. And sample variance is the sum of the squares of deviations for all values divided by their respective number of observations for this population variance, and number of observations minus 1 in the concept of sample variance. Okay, easy. So now let us move forward and try to see what if we altered the data. Okay, because this is a very interesting topic and worth studying in this. Okay, what if we add a constant? Okay, what if we add a constant? That means we are now making yi is equal to xi plus c. Let y dash be the mean of new data set, and y dash is equal to x dash plus c, we know by our earlier discussions. So if we try to find out yi minus y dash, what it would be? It would be xi plus c for yi, okay, minus x dash plus c for this y dash, right? So we are just opening the brackets, and we'll get xi plus c minus x dash minus c. This c would get cancelled, and we are left with xi minus x dash. So now you can see that there is no effect of adding a constant in this variance. Okay, so we can say that new variance, okay, new new variance is equal to old variance in the case of adding a constant to all the values. Okay, let's move ahead and try to study what if we multiply a constant. So again, yi is equal to c into xi. Okay, so if we are willing to find this as yi minus y dash deviation, then what we'll get? We'll get c into xi minus, what would be y dash? Y dash would be nothing but c into x dash. We have studied it earlier. Okay, c into x dash, right? We can take this c common and this xi minus x dash will be as it is. Now actually these deviations are getting squared in the case of variance, so it would be c square into xi minus x dash squared, right? So all these c squared, if we will think, then the variance, new variance, c square x1 minus x dash square, c square x2 minus x dash squared, and so on up to, since we are using x dash, let's take it as sample. Okay, so what would be the next? We can take the c square as common and we are left with the old variance, right? So this is the thing which should be again committed to the memory. New variance is equal to c square times the old variance. Okay, yes, yeah. Now if now when we have studied all these things, then studying sample deviation, standard deviation would be easy for us. Okay, standard deviation, and this is nothing but sigma is equal to under root of, since we have removed the square, then we have to put a square root in the RHS, which is equal to x1 minus x dash square plus x2 minus x dash square, and so on up to xn minus x dash squared, right, upon what? N minus 1. This is the case of sample, and similar, there would be a similar case for population, right? Yes. So this we have studied the what does standard deviation means. Now let us again alter the values and find what happens. So if we add a constant, what is standard deviation actually? Standard deviation is equal to square root of variance. Okay, this is true. So the changes in variance, if we add or multiply with a constant, would affect standard deviation. So what happens if we add a constant, then the standard deviation will not change. Okay, as we have seen in the concept of variance, because new variance is equal to old variance, so there is no changes, so square root also will not change. And multiplying with a constant is again helping, because new standard deviation is equal to c times old standard deviation. Okay, why so? Because the new sample deviation in the case of variance was c squared times the old variance, right? So what is standard deviation, it's the square root of variance. So new standard deviation would become c times the older standard. Now the question arises, why we need this standard deviation if we have this variance? It is because here all the values are getting squared, right? So the units associated with them will also get a squared. So if we want to find the variance of heights of students in a class, then the answer of variance would come in, meter or fit. We can say that fit is squared or meter squared or centimeter squared, whatever the unit is. Okay, so all the data is in centimeter, or all the data is in fit, and the variance is coming in feet squared or meter squared, then we can't say that we have attained our aim to find the variance, or we have attained our mean to find the dispersion. Actually, how much it is dispersed. If the unit have squared, that means there is something wrong. Okay, so to balance this, we took this notion of standard deviation, and here the units won't change as because due to the square root, the variance, the units, if it is feet square, it becomes fit, or meter, it becomes meter, kg squared, it becomes kg. Okay, so due to only this point, concept of deviation was introduced, sample deviation, standard deviation was introduced. Okay, yes. The next thing is percentiles. Percentiles. Okay, now what is a percentile? So a percentile is nothing but a measure used in stats indicating the values below which a given percentage of observation in a group of observation fall. Okay, so it's just a location kind of thing. So if we I'm not going to the definition because it may confuse you. You should know what the concept is and just apply into the questions. Okay, so if we write that 20th percentile is the value, or let us, for an example, let it is score. Okay, then what we can conclude is that it's a value below which 20% of the observations fall. Okay, it is that value below which 20% of the values fall, right? So the concept of percentile is like this. Now let us try to know that how to compute percentile using this IIT slide. Okay, so to find the sample 100p percentile of data set of size n, arrange the data first in increasing order. So actually what the scenario is that percentile is also a position, and recall that median also was a position, right? So the way we have found the value of median, okay, and the way we will find the value of percentile would be not that similar, but the concept of both of them are actually similar. Okay, median is actually the 50th percentile. That means it's that value below which 50% of the observations fall, right? It's the mid value which we have. Recall that all these things are interrelated. Okay, and when we'll compute the first percentile or something, all these things, then we are using similar kind of concept or ideology. Okay, so let's start. Arrange the data in increasing order. The first thing you need to do, as we have done in median, if np is not an integer, size is n. Okay, and p is what? P will denote the what kind of percentile you want. Okay, is not an integer, determine the smallest integer greater than np. Okay, smallest integer greater than np if it is not an integer. Okay, the data value in that position is sample 100p percentile. Okay, if np is an integer, then the average of the values in position np and np plus 1 is the sample 100p percentile. Okay, so you may recall that the working style is quite the same as we have done in median. Okay, not very much same, it's about, I can say that 15% same, because there are two procedures for it if it is not integer and it's an integer. Here there we have two different procedures if the value of n is odd or even. Okay, so yeah, let's take here the value is n. So what is np actually, or 100p? 100p is the percentile. Okay, so if we ask you to find the 25th percentile, that means 100p is equal to 25 and p is equal to what? 25 upon 100, which is equal to 0.25, right? 0.25 would be the value of p, which we have to multiply with n. Okay, so let's start with this. There is the value of n is given and there were 10 data points which are arranged in ascending order for you. Now you are asked to find the 10th percentile. Okay, so see, if we have to find one first percentile, then 100p has to be equal to 1, p is equal to 1 upon 100, which is equal to 0.01, right? And if we are set to find 10th percentile, then we have to put 100p is equal to 10 and p has to be equal to 10 upon 100, which is equal to 0.1. So you should know how to interpret this value of p. P is what? P is the 10th percentile, and np, the multiplication of n with p, is giving you 1. Okay, and this is an integer. That means the value at first position and the value as np plus 1, that is second position, will take the average of both, and that would be the value of the first percentile. So what is the first value here? It's 35 and the next is 38, and they have taken the average of all of both of them and they have found it to be 36.5, right? Similarly, here they have found the 25th percentile and they have again multiplied it n the value of n with p, and they have got what? 2.5, and it's not an integer. That's why the position the value at the position of 3, because the procedure says that if it's not an integer, determine the smallest integer greater than np, right? So smallest integer greater than 2.5 would be nothing but 3, and it would be third value is 47. And with this process you can find all the values of percentiles, right? So let's move ahead and try to understand what this thing wants to say us. Okay, this thing wants us to know the value of quartiles. Okay, this is actually telling us or giving us an introduction, or the prerequisite for the definition or for the concept of quartiles. Okay, so the first quartile is equal to, the first quartile is equal to 25th percentile, right? Second quartile is 50th percentile, right? And the third quartile is 75th percentile. Okay, so this thing was the main thing which we have to study using percentile. Okay, what are quartile? First quartile is 25th percentile, second quartile is 50th percentile, and we know it with its nickname, which is median. Okay, median is the second quartile. Third quartile is the 75th percentile, right? Now comes the concept of our next measure of dispersion, which is nothing but our interquartile range. Okay, and interquartile range is defined and written as IQR, which is equal to Q3 minus Q1. That means difference between the third quartile and the first quartile is known as interquartile range. Okay, interquartile range, we have this thing is known as interquartile range, and this interquartile range is actually used in finding the values of outliers. Okay, which values are outliers and which are not is given by this concept of yes, interquartile range. Okay, now let us first try to, we have studied all the measures of dispersion, and let one concept is left, which is the 5-number summary. Okay, 5-number summary is left. The 5-number summary. So the name suggests that these include 5 numbers which will give you a data, or we can say some which will tell you something about the data set. Okay, the first thing is minimum. What is the minimum value of the data set? Next thing is Q1, that is the first quartile or 25th percentile, right? The next thing is Q2, which is second quartile, and this is nothing but your 50th percentile. Okay, and it is also known as median. Okay, next thing is your Q3, which is equal to third quartile, which is 75th percentile, right? And the last thing is the maximum, okay, which means the greatest value in the data set. So these are in number 1, 2, 3, 4, 5. So these things include, or we can say these things constitute the 5-number summary. Okay, so we are at the verge of ending this lecture, and one more thing left is how to find outliers using interquartile range, which is a bonus point which I am telling you. Okay, how to detect outliers. See, outliers can be detected either by just going through the data, because those values which are quite more than required, or than the other values are the upper bound, we can say, of the upper value of the outlier, and which is least as compared to all the values, or the required, you can say that comparatively very less. Okay, would be the outlier which is at the lower corner, I can say. So detection of outliers is generally statistically done by this. We can take a range, okay, in an interval at Q1 quartile 1 minus 1.5 times the interquartile range, and this is the lower bound. The upper bound would be Q3 plus 1.5 times the interquartile range. Okay, and all the values which are exceeding or below this particular range are outliers. Okay, data point which lie outside this interval, we can say, okay, are outliers. Okay, so this is the way or statistical way to find outliers. However, we can find the outliers just by an inspection. Okay, so this is for all. This is the revision of week 3 contents, right? And I hope you will do best in your examinations. Thank you very much.